Good morning, everyone, and welcome to the 13th ETP's webinar. Today, Andreas Wirse from Cycos will present you different aspects of sustainability in HPC. And I'm Maria from ETP4HPC office. I will be the host of this session, and two of my colleagues will help us today. Pascal will take care of the chat, and Michael will moderate the session. Before we start, here are some practical details. This webinar is recorded as usual. You will receive the link to the recording on Monday. This webinar is in listen-only mode. You can communicate with us, ask questions via the question pane of the GoToWebinar control panel, what is illustrated here. You can ask questions, send remarks there at any time during the presentation. We will answer you online, and actually we will share the questions to Andreas in the chat, and he will answer these questions during the Q&A session after his presentation. You can also download handouts from the control panel. You can find there the slides of the webinar and also 4 ETP4HPC white papers. Michael will present these later quickly. Today we have one speaker, as I mentioned, Andreas Wirse from Cycos, and before he will present you different sustainability aspects, my colleague Michael Malms will introduce you quickly the background of this webinar, and at the end we will close with a Q&A session as usual. Michael, I give you the floor.
Okay, thank you, Maria. So let me say a few words before Andreas starts over. First of all, it's important to understand that we are doing various white papers this year. You see that we have already 6 on our Zenodo platform, 4 coming from the ETP, focusing on HPC and associated areas, and then 2 TCI white papers. And when you go to the ETP website, click on Zenodo and you will see them, you can download them. And Andreas is going to talk about another one that is not yet available, but it's in the final stage of being finalized. I think this is a very important topic because sustainability will be at the center stage of our next issue of the SRA 5. Which is coming out mid of next year, and we think that given the political directions of the EU, given the discussion about global warming and about CO2 reduction priorities, sustainability is also important for the area of high-performance computing. There are multiple facets, and Andreas will give you an introduction to this. If you are further interested, if you would like to contribute, if you have ideas, send me an email or send email to the office, and then we can certainly welcome your input and your feedback as well. Next slide. There's, I think, one more. Maria? Yes, here's Andreas. So Andreas has multiple hats on. He is, first of all, besides being a member of the ETP through his company Cycos, he's the managing director of Cycos, and Cycos is supporting SMEs in the uptake of smart data technologies. His other hat is more, let's say, dealing with bigger companies like Porsche T-Systems and providing services for their use of simulation and modeling through HPC. This company is located also in Stuttgart, close to HLRS. And there's also part of the SRA authors team, the technical team. He's co-chairing the working group on application co-design together with Erwin Laure. So Andreas, welcome. Thank you for spending your time on this topic. And now the floor is yours.
Yeah, thank you, Michael. Thank you for having me. In order to share my slides, I just have, well, this should be the right window. Now you should be able to see my slides, I hope. Yeah, so sustainability, I say it right away. For me, this topic is, well, in a way, fairly new, especially in the HPC context. And this is actually my first presentation on sustainability as well. And that's why I thought, how do I address this? Because probably some of you in the audience know even more about, or know more about sustainability than I do. But I volunteered to work on the white paper that Michael has mentioned, because I think this is an increasingly important topic. And I would like to take you on a brief trip how in a way I joined, or I started looking at sustainability. And so first, I would also like to mention that in the white paper context, I'm supported by Pascal Laurent and François Baudin. They are both working with me, and there's also input from them in my presentation. So, but when I started, the very common way is, well, you Google a little bit, and when you Google sustainability and HPC or whatever, I came across several hits, and when I took a closer look of them, I noticed that they usually address energy usage, power usage, energy intensivity, which is kind of obvious because energy is related to the ecological footprint, CO2 footprint, whatever. But it's still surprising that most of these links are just about energy efficiency. Some work on the efficiency of the computers themselves, and others try to use, let's say, environmentally friendly energy like solar energy, so renewable energy in a way. There's really a lot of things that are circling around of energy. So that was the first impression that I got. And so I looked a little bit deeper into this, and Michael mentioned this. ZCOS is closely related to HLRS especially. So they are doing or working on sustainability since a while. So the first people I asked about this were the colleagues there, and I stumbled across then some schemes like EMAS, Eco Management and Audit Schemes. That's an instrument that has been developed, as you can see, almost 30 years ago. So this is not something that's completely new, but it's actually very mature. There's an international environmental management standard related to that with an ISO 14001. But there are also standards for energy management systems. And the definition I found there is, well, you have a forward-looking, organized and systematized coordination of procurement, conversion, storage, distribution, and use of energy to cover utilization requirements, taking into account ecological and economic objectives. So taking into account is kind of the last part, the one that interests us. But you see, forward-looking is it's into the future. It's kind of doing this in an organized way, and actually the middle part, it's covering everything: procurement, conversion, storage, distribution, and use. So it's really an overall view, perspective that one should have when looking at that. And I also found this looked a little bit complicated. This is how these are related to each other. So ISO 14000, for example, is fully part of EMAS. With ISO 50000, there's an overlap, but there's also another DIN, which is about data centers, where you also find aspects around sustainability. So you already see this is not, let's say, a very simple thing if you want to be well, sustainable in that sense. Along that line, there are some things you have to consider, and that's actually what HLRS is doing since a while. So you see on this slide, it's actually from the webpage from HLRS. There's already the EMAS logo, so they have a certification, and there's also the Blue Angel, as it's in now. It's also about environmental protection. And what I also find very well, pretty surprising. They started all this also many years ago. Almost 7 years ago, there was the first sustainability report. So they have quite a good history. So I think they were a good partner to get going. And what I would like to show you now, the next slides are some well, ideas that were developed at HLRS. And so they have a sustainability program, and they asked also their employees what they could do, and there came a lot of new suggestions, and they show already that it's in the way of thinking going beyond pure energy. So the first one already is very nice. Expand training for clients regarding efficiency in programming. So there's not even the word of energy in there, but it's of course clear if you're more efficient in your programming, your program will run faster, and it's very likely that it will use less energy, which comes back to what we started. But you see, there are many indirect effects as well. There's also the idea of looking at the supply chain management. So again, this is something we are not just looking at the CPU of a big computer and make this more energy efficient, but there's a lot more around that where you can also be supporting sustainability. And such things that we all know since a long time, do we need printed matter, reduction of printing of brochures, etc., when possible. That's something that even nowadays in the pandemic, if you go to trade shows or so, you usually you tend to get some papers, brochures, etc. Well, actually at ZKOS we are working on our new brochure since about 2 years. But well, the need to have a printed brochure currently is not that high because you rarely meet people. So those are also things that influence well, the environment sustainability. And also the documentation concerning this in training courses and online courses, this is more something like an awareness thing. So here I already got the impression that this is a little bit more than just energies. And there are also ideas that well, are currently under consideration. They are not yet put into action. But for example, using physical, in this case, login nodes in a more efficient way, having virtual login nodes, group them better to combine users who have lower requirements, and then you can reduce the number of server systems. Again, this is of course targeting energy, but it's going beyond that, because a login system, a login node is actually a physical thing that also costs money, but also needs resources when being built, not only the energy. And also upgrade aging storage components with new systems that have only a fraction of the components. Also, again, making things simpler usually has a positive effect on sustainability. And there's also sustainability in research and training. So the examination of training events, the selection of relevant lectures and practical training to mirror that, develop specific events, integrate, for example, test questions on green IT and energy efficiency in these training programs, again, to increase the awareness of the participants in these courses. And also use user energy efficient hardware in these training models. When you're talking about computing architecture, it's actually pretty natural to address also these issues, but in many cases it's not yet done. So this is something that, well, actually, if you think about it, it's not a big deal to do it. And those are things that are already implemented at HLRS. There are other ideas. So to increase research activities to improve the energy efficiency in the production process. So it's not only about running the system, but it's also about being more efficient in the production process. And also, well, send research, and we are talking also about the scientific research agenda that Michael mentioned, can contribute a lot to improvements in efficiency. And this is something that's also ongoing at HLRS and that also influenced significantly what we are discussing in our sustainability white paper. There are also projects that are already implemented. In this case, it's about infrastructure. So the green building, you see, it's really nice painted green, but there's a lot of energy going around in there. It's about improving the field free cooling percentage and really reorganizing, renovate cooling here in order to be more energy efficient. Also, an additional temperature increase in progress, which would reduce the amount of cooling. That's something they probably cannot do on their own, but they, well, as they say, put pressure on it, try to bring forward these topics. And there are also modernization of the dry cooling pumps, for example, something they already have done. But there are always things that you might be able to improve. So, and there are all new challenges, or sometimes also old challenges to accept in order to improve things. In this example, the dry coolers. So, if you're more interested in that, there's some activities documented pretty nicely on the HLS webpage. So I put the links here. So if you're interested in that, just pass by there and look what they are doing. Some things are only in German, but most things are also available in English here. So that brings me now closer to what I was then starting to rethink what exactly sustainability includes. How is it defined? It's probably one of the most widely used words nowadays, but I think the interpretations that you will find are also very, very many of them. So I took a step back, and I have a friend who is he studied forestry, and he's working in this since many years. And I think how people work in forestry is really a very, very good indication of what sustainability thinking, what sustainable thinking really means. And he told me that well, when he goes out into the woods and is going to harvest trees, those trees have been literally planted by his grandfather. So he's, in the moment he goes into the forest and gets things out, he benefits from work that people have done decades ago, 20, 30, 40 years, even more. And on the other side, when he goes out there and plants a new tree, it's very likely that he will not be the one who will harvest from it. So he's thinking about his own grandchildren who might be in forestry, and they will benefit from the work that he's done. So actually everything somebody working in forestry does either is based on work that others have done for him, or he's doing work for others, and he will not personally benefit from him. And this is what you see in this slide here, where it takes already a long time, well, for the trees to grow. This is about pine trees actually, so the figures, the years are should be correct. You see also there are different phases. There are also, it's not that you just only have to wait until the tree is grown until you get it. You can, for example, there's a first commercial thinning after 9 to 12 years. There's another one 10 years later. So it's not that it's only a long-term thing. There are many things going on, but the important thing is to have in mind the overall picture and not just think about what you are experiencing now. It's also about thinking what others in the future may have to do. So this is, I think, is a guiding thought that brought me then closer to looking at, well, what aspects of sustainability do we actually have? And this is I think a pretty common model of this. There's also something with 3 pillars, but what I like here better is that the 3 circles, the social one, the ecological one, and the economic one, they actually do overlap, which is not the case in the pillar example. So they actually overlap, and the real sustainable part is when you manage to get all the 3 aspects well into one. So where all the 3 circles overlap, that's kind of the core of this sustainability. And many people just look at the ecological side of it, at the environment, and we all know that working in the HPC industry, the economic aspects cannot be neglected. And since we, on one hand, also have employees, people we work with, but also that we are addressing problems that the society might have, the social aspect is also really, really important. I noticed that it's getting more and more important right now over time. This was probably a little bit different 20, 30 years ago, but by being visible also, if you do climate simulations, you're in the public, or if you do hurricane path simulations, you're visible. So HPC is much more visible now, and therefore also the social aspect is really, really important here. So I've just brought a few examples. Then, if you look at ecology and environment, sorry, there's a typo in there. Well, environmental protection in order to maintain an intact livelihood is something that's well, straightforward. I also addressed already climate protection by use of energy, of course, and have sustainable mobility, but it's really a social aspect, which then comes to the second part. Well, accept social responsibility. It's not just all about business, and in turn, actually, even the social part is reflecting on business. It's about creating these healthy and safe working and living environments. Again, you see there are many aspects that not necessarily have energy in them, and there's also not necessarily HPC in them, but you can really relate to them. And on the economic side, of course, we have economic security issues, but also there's a reputation. Corporate social responsibility is something that's been very popular, grown very popular, but this is just more than this is really also about the economic values that are behind all this, and you cannot think those three independent of each other, because if you're economically not successful, it will be very, very difficult to do the right thing, to fund the right things. So it's every part is really important. So which now brings me to our white paper. When Michael, well, actually, I think it was Michael approached me. I said, okay, I'd like to do this. We have a team. So there's Pascal Rosleron, I already mentioned, from Athos, and François Baudin from Irisa, who's active, supporting us, working with us. We're working together. And as Michael said, it's not ready yet, to be delivered soon. I have a kind of, well, once in a while, I talk to Michael and say, well, we probably need another week or two, but this is all for the sake of quality, and we reached already a level where I thought it's probably a good idea to well, to share these thoughts also with you, with others, and I think it's actually a pretty good time, because since we are not really finished, even if there are some ideas coming up today, if you have suggestions, etc., we'll be able to take them up and consider them and kind of modifying our white paper as it's now. So the key points we have, and those are the ones that I would put up for discussion actually today. We have developed some key insights, and we came up with some key recommendations. And what you see is, let's say, version 0.3 or 0.4 of that. So we discussed this a little bit, but we are still open to suggestions. So the first insight I kind of also addressed already a little bit. There's a lot of emphasis on the optimization of CPUs or systems even based on performance per energy, watts per flops. And we think that this is, of course, okay, but if you're only looking at that, this is too narrow. There is much more, really much more that should be taken into account when thinking about sustainability in HPC or data analytics, artificial intelligence. It's not just about the CPUs and their use of energy. Also, the CO2 footprint of a system is not only set during the operational phase. It's not about just the energy that is used while the system is running and computing your job, but there's of course considerable influence in the design and manufacturing phase. So how do you design the system? What components will be in there? And also depending a lot on, well, what happens to the system once it goes out of use? What will happen with the parts that are in there? And if I look in the design and manufacturing phase, we discussed, or I presented already a little bit the energy aspects that came up at HLRS, especially cooling temperatures, etc. And a system that has high temperature cooling, this is a design decision. This is nothing that you can decide once the system is there. But if you want to have a system which uses high temperature cooling, you have to design it in this way right from the beginning. And also when it comes to manufacturing, well, if you see manufacturing together with the destruction phase in the end, when the last Cray we had, Hermit went back to its vendor after it was taken off duty, so to speak. We were all wondering what's going to happen to those parts that are in there. We asked a little. I didn't get much information, but I guess some parts are shredded. Some can be reused as they are. But I had the feeling, and that's a few years ago now, that, well, let's say there's potential to think more about this. And this is definitely linked very closely to the manufacturing phase, because that's what you start to see in cars already. They are increasingly built in a way that you can disassemble them later on with the different materials, easy to separate. And that's something I think has to be, I must admit, I haven't been in the production of an HPC system, but the feeling that I've got is, that we have got, it's not only my idea, we are working on a team here, is that there is at least some potential to improve these things, or at least to think about what could be improved. And then there's a, how do you say, something I also noticed. I mentioned the Cray went out of use. We have a new system, the HPE Apollo system in Stuttgart. And when you look at the pure clock speed, actually, I think there's no difference, or the new clock speed is even a little bit slower than the old one. And well, I remember the times when I was young, I'm already that old, that when I got a new computer, it simply had another CPU of the same architecture with double the clock speed, so it went twice as fast. So it was as easy as that. But this is no longer the case. We see now that the clock speed is not growing anymore, not really, since a while already. What we see is we get a lot of cores. We get more cores than from the previous system to this one. In Stuttgart, we had about, I think it's more than 3.5 times the cores, which kind of accidentally is about the speed up that we also notice. So you could ask now, well, if the CPU is not getting faster, I could probably use my CPU a little bit longer. Naturally, this of course is related to the energy question, because the new system is faster, more than 3.5 times, but it doesn't use 3.5 times more energy. So there are, it's not that simple. But I think there are some aspects that have to be taken into account, and this will, if the useful life can be extended, and I'm not, well, I don't want to have HPC vendors going bankrupt because nobody needs a new system because the old one lasts for 20 years. That's sure not what will happen. But I think we have to look into what could be done to extend the useful life in one way or the other. Because this would also allow the code developers to better tune their codes. And that brings us back to the example I had in the beginning. If the code runs faster, it will be using less energy. So, and this means there is, we have to justify the effort for improving the code. And this is easier if this code can be used for a longer time. And we have really put the word architectures here on purpose, because this is something that goes beyond the CPU alone. This can address other issues around. We'll come to that in the recommendations then later. Of course, and energy efficiency of the code, that's something that's handled anyway. Not easy to do, but people are working on that as well. But this here goes beyond. And then something that goes a little bit further again, when HPC systems are integrated more strongly in the productive workflows, which is especially relevant when it comes to industry, because they have much more well-defined and tight and controlled workflows. This is getting more and more important, and also here a longer useful life of the system will help them, because especially when it also comes to validation, for example, if I think of the automotive industry, crash simulation, this needs to be validated. They are pretty reluctant to change versions of their simulation code during the work on a single project, and they are even less reluctant to change from one system to another. So if we are getting better here and can extend the life of these systems, the useful life of these systems, this will make it better for them, and the investment into their workflows will be even more reasonable. And that's something that will increase the overall productivity of the usage of these systems, and which in turn will then have a significant impact on the sustainability aspect, the corresponding footprints. So those were 4 key insights we came up with, and of course we also thought about what could we do about it? What shall we do about it? What would we like others to do about it, think about it? It's a scientific research agenda, so it's clear we don't expect that all these things will be put into action tomorrow, but we want to give a few hints where we think helpful developments could go. So one idea is to have this whole ecosystem. I'm not just talking about the computer system, but everything that's around, build more their systems more modular, and not optimize so much just the single isolated part they are working with, which is of course natural. You're trying to do best what you can influence, but we think that we have reached already a level that this optimization of the single parts is well, it's pretty advanced. It will be more and more difficult to make more progress there. We think that in the playing together of these elements of these systems, there is much more room for improvement, for optimization. And when we are able to build, on one hand, systems modular, in a modular fashion, and on the other hand, have the overall perspective, including interfaces and how these modules fit together, there's a lot of potential that will not only benefit the sustainability question, but this will make also the usability of these systems, will improve them. The efficiency might even be better. We think that this is something that's beneficial actually to the whole complex. And in order to support this, we are trying to be a little bit more concrete. We think it's important, this is really a kind of low-level activity, establish opportunities to bring these people together, to the stakeholders together, make them talk to each other, develop ideas together over the supply chain, so to speak, in a way. And especially also increase the awareness of the roles they play, because they are in many cases just focused on their own part. They are not so aware that they might have also influence, let's say, some way up the supply chain, the food chain, so to speak. So that's something. This is about awareness. Bring people to think about these things. Another issue is a little bit more concrete regarding, well, the ever increasing amount of data, and also, well, the movement of data. And the idea, well, we have IoT applications where sensors are collecting data worldwide. They are probably collected in distributed computing centers. And those data, this data is growing so much. We are about to have well, to lose the ability to move all the data into one spot to get it together. So we have to work on the ways that data can be moved. Well, of course, we have to improve it, but at the same time, we have to understand that we probably cannot move everything that we want. And sometimes we have to also reduce the cost that's related to the amount of data that we have in order to have that from the economical side, but also from the ecological side as well. Then, of course, it's important to improve the power efficiency of data centers and supercomputers. That's definitely, we are already on this way. There is significant progress, of course, but we definitely think there's a much more that needs to be done, and want to support this strongly. And then finally, we want to have we want you to put all of you to put more emphasis on the usability of the systems and the better workflow integration as intended, because that's something a lot of the HPC, the high-end centers have a research background or an academic background, but what we see is that industry is increasingly using these systems. And as I said, these workflows and also the people working at development engineering departments of large companies, they have quite a different setup compared to the PhD student, for example, who's working on a new PhD thesis on a new algorithm, for example. And I think that it's, or we think that it's really important to take this more into account than we do today, in order to make, well, the usage of these efficient systems more efficient, because, and that's something that's a more general point, I think a lot of the computations that are performed, either HPC or data analytics, AI, actually help a lot to improve sustainability in completely different fields. So it's not only that we have to get better, but when we are good, we have more influence somewhere else. So there's really a leverage that we could use, and it's not just about us, but it's also about, let's say, if we do computations to improve the energy efficiency of a water power plant, that's a clear computation that we can reach much more. Then, for example, we can save much more CO2 there than we need to perform the computation. And that's something, the easier it is to use this system, the more people will use it and benefit from the potential that we have here. And that finishes my part almost in time, so to speak. And well, the idea of this presentation is actually to get into a discussion. It's not about presenting what we do and get applause from you, but it's really we would like to hear from you. What do you think about this? So I'm trying. Well, I didn't look at the chat yet, so I don't know how. Michael, will you help me? I see there are probably some questions.
So I don't know, between Maria, Pascal, and myself, are we going to show the questions, Maria?
The questions are in the chat. They are already shared with the audience.
Ah, okay. So then let me just look here.
We have three questions. We have two questions and one comment, really.
Right. Okay, so there's one question from Leonique Mevius, and the question is, do you also have ideas on how to reduce the production, since that is where the biggest footprint of IT infrastructure is, CO2, water, and the use of rare natural resources?
I frankly admit no, because I'm not an expert in this, and I think neither Francois nor Pascal are experts. That's actually something where we would like to get into discussion with the experts, so with the HPC, the developers of the systems. And I think this goes very far, because well this includes companies like Intel or HPE, but it also might include companies like BASF, who do the chemistry, or Trumpf, who produce the systems, who for the wafers to write them, all this. So this is, I think this would be covered in our first recommendation. Get stakeholders together and talk about these ideas. So we don't have these ideas, unfortunately. At least I do, and my co-authors also, they don't do.
Yeah, and I think your point is well taken, that you know, we don't have answers ready yet, and I think this is the starting point of a collaborative discussion in the upcoming months and years. Bring the players together and let them talk to each other. There's another question here that is going into a direction that is obvious. There are a lot of claims and no proof. Where is the data and the references? A question from Michael Barne, or Michael Barne, I don't know.
Well, that indeed is a very good question. Well, I think you have parts that are measurable, right? So if we are talking about high temperature cooling or so, it's measurable that energy can be saved. What's measurable is, for example, if you write more energy efficient code, yeah. This is, of course, this is not giving 50%, just a few percent, but that's also measurable. Many of the things that we propose, I think, would also be measured. So as you said, Michael, this is a little bit related to the first question. So if we look at or let's say the first step from our perspective now would be to define, or to measure the footprint that the production of a system already has today. So I don't know whether such a footprint has already been calculated. It might be that the providers do this internally. I don't know. I haven't seen one. Probably somebody has seen something. So if it's there, we have something measurable. If it's not, we think we have to get there and do something measurable. When we are talking about workflows, it's also, in a way, it's measurable. So I'm working with for example, with Porsche. Porsche has implemented its own workflows. I don't know the exact figures, but I know they spend money on a consulting company to implement their workflows and to make them. And they are working right now. And whenever a new system comes, they have to spend more money on the new workflow, to adapt the workflow. Again, this is measurable. Or even if I don't have the figures here, they are. And I don't know, we have other people from industry in our audience. I'm pretty sure there are several people who also, if they would take the time, if they had the time to come up with these the data and the references, we would be able to. But the question is really important, because it's clear we will only be convincing if we are able to provide the data and the references. So this is, I would rather take up these questions and kind of, well, I discuss with the others, but that's something probably that we should take into our recommendations. Make these effects more transparent, because, as you say, as long as we just go around and claim it's like that, we might convince those that are already convinced, well, which doesn't help. But in order to convince the others, we have to deliver proof. That's homework we have to do.
Yeah. Okay. Thank you. Then there is a comment from Henry Strauss. He says, I doubt that the stagnating speed in terms of clock speed will lead to a longer lifetime of systems. Just look at the standard procurement cycle at centers. It has been around 5 years for a long time, and I do not see this to change. This is because of improved system performance due to a higher number of cores adding accelerators, etc.?
Yes, this is true. I also said that energy efficiency also plays a role, but I have, let's say, actually we have in Stuttgart we have two systems, or well, we have many systems, but there are two larger ones. One is the huge Hawk, which is replaced every 3 to 5 years, depends on the developments. And there's another system, Vulkan it's called, and there we have actually, let's say, a first version of a modular system. Because actually, I think the system stands there since I'm there with CCOS, something like 8 or 10 years. And I don't even know whether any electrical part is still the same, but the racks are still the same. And what happens is there are different generations of CPUs in there. There are, I think right now, there are probably Skylake and Cascade Lake and whatever. There used to be Haswells and Broadwells and I don't know, I don't remember all the names. And when a new generation comes, those cores that are not used anymore, and there's a lot of industry use on this system, so they have a good feeling where the cost efficiency of the system is, then they will get, they take them out and bring in the new ones. And for example, I remember, well, Nehalem is also a name of an architecture. We were pretty surprised how long Nehalem cores CPUs were used, although there were already the faster, I think Haswell was the next generation, or even Skylake in the system. And but they were used and the customers paid for them, although the cost performance ratio would have probably been better with the newer CPUs. But why? This comes back to the workflow. They had a well-defined environment. They didn't want to switch the code. So it's not only the pure price performance ratio that's important here, especially from the industry that I know. There are other needs that might at least extend the lifetime for another year or even 2. Really, we were surprised how long this was valid. And what I would like to do is, it's not that we are trying to prescribe something. What we want to do is we want to start the discussion and bring, let's say, more information at the table and make sure that nowadays people are using HPC systems in a different way than we used it. And Henry, I know you're in this business for a long time, even longer than me. And for me, it's already 25 years. Some things are different, and we just should be open to take this into account, and that's the idea behind.
Okay, thank you. There is a another comment from Michael Bain. He says that yes, a lot of this data is already being collected. He asked the question about the data before. There is a bird of a feather at supercomputing coming up in 2 weeks. I'm happy to help doing the connection, and I think we should take up on this. And then, of course, for everybody to know, there is also a similar meeting or session organized by the ETP4HPC, also focusing on sustainability. Can fast be green, right? So maybe we should connect here. Let me, Andreas, maybe when you were talking, I was thinking about something else. I had a connection with a startup company some time ago, and they're running a compute center in the northern part of Germany where the windmills are turning.
Yeah, I know them. I don't remember the name, but I know them. Yeah.
And they're saying, well, we have so much wind here, and we have all these windmills, and the energy is not funneled through, let's say, pipes into the southern parts of our country. So we have excess power here, and sometimes even, since the energy cannot be absorbed, the windmills are being taken out of a rotation. Yeah. So he says we'll have almost, let's say, free of charge energy. Why do we not put HPC centers where energy is cheap? You can go even further and say, like in Finland, you have, you have even water in old paper mills free of charge. So the answer to why is this not happening is because politics. In many cases, there is European, let's say, government funding behind new procurement cycles. They want the system to be next door. They want the system to be in the country, or let's say even in the region. Yeah? Why not think about, let's put the center, even if it's, let's say, working for somebody else, where energy is cheap. Then of course, transmitting data forth and back is counterweighting this, but thinking about, why do I need my center next door?
Well, that's something that definitely, actually it's not a new idea, because BMW, I don't know how many years ago, they put one of their computing centers on Iceland, to Iceland.
Yeah.
I think they in the meantime also have something in, I don't know whether it's Sweden or Finland, and they are doing this already. And I'm absolutely with you. The politics, our minister president, he wants to tell everybody we have a great computer here in Stuttgart. And this is actually not to be underestimated, because it's not just about having the computer, but there's an ecosystem around him. So I do understand this to a certain level, but I absolutely agree. We should think more about this. Yeah, and also I don't know. It's just an idea coming to mind. You could, for example, even, well, I don't know whether this economically makes sense, but when you have fluctuating wind power, you could probably also have fluctuating usage of systems. So you have a system that's large enough to always work when the wind power is coming, and you load it depending on how much power you actually have. You could have even, if your job is not so urgent, you might benefit from putting it into a longer queue, which waits for excess wind. Those are all ideas I think we have to think about. And I had a discussion about climate change yesterday in another context, in a political context actually, and several people said, and I fully agree, many companies are thinking are much further ahead than politics is. So they really look at it with a, well, of course, with a pure economic perspective, but this really, it also makes economically sense. So the windmill power, I think it comes down to 3 to 6 cents per kilowatt hour, while a nuclear power plant has 25 and coal has 9 or 10. So it's not only about sustainability, it's also about economically. And if we work with a startup like the one that you mentioned, I think what we can do is we can support to spread the news. And this puts us back to recommendation 1, awareness. Yeah, I'm sure there are many things that are already there that could be we just have to do it, but nobody knows, or the right people don't know about it. That's something we definitely can work on together.
Okay, good. Let me see. Oh, there is a long comment from, I cannot, I mean, this is too long.
Okay.
It's not that long. There was a cut and paste bug. I pasted the end twice. So,
Pascal, you read the part that is not there twice.
okay.
Yeah.
You want me to read it? Okay. Hi. Yes. About production, fab, and also decommissioning footprint, IT infra, etc., CO2, water, and the use of rare natural resources. It is necessary to first identify more precisely the contributions of the different parts out of a very complex and distributed, delocalized value chain with many providers. Also, the whole life cycle does matter, from fab to commissioning and operations to decommissioning. At CEA, we have started a dialogue with Atos on these aspects, and they are in the process of having more precise elements. Well, Pascal, not me, the other Atos Pascal, she could tell more about this at some point. note,
Okay.
we have a forum ORAP on these topics on December 7 and 9. That's in France. That's in French. It's a very good event, but in French. Online event, but mostly in French. Everybody welcome, free registration, and that's it.
Okay. Yeah, so there's awareness all over, and I fully agree. This is what you said, Andreas. We need to look at like, you know, for electric cars, they seem to be so efficient, but when you look to the production, it's less obvious. So we need to have an end-to-end view here. Okay, good. So I think that's it from the chat. Yeah. Okay, thank you, Andreas, for the ideas that you brought up. And as I said before, we're going to have this white paper. Maybe a few new ideas come out of this discussion here that make it into the white paper. Well, certainly this will be an ongoing discussion. Oh, there is one comment coming here. Thank you, Michael, for that question. Our CSC colleagues, yes. Our CSC colleagues in Kayani are looking very much into this and would be happy to follow up on follow-up data on this. The potential of collaboration or collection has not yet been fully explored. Yeah, this is what I mentioned.
Yep.
And yeah. Okay. All right. So, Maria, back to you.
Yes. Second. Okay, it's working. So, okay, I'm sorry, it's working. So before we close, Andreas, thank you again for the presentation and then to give us the opportunity to have a look into where you are in the white paper preparation. And also thank you, Michael and Pascal, for your help. Before you go, I would like to ask you to please fill in the short survey once you leave the webinar. It could help us to improve the upcoming sessions. This year we will have one more webinar that will be on quantum on the 10th of December. You can already register via the link on this slide. And thank you for being with us today. And I wish you a nice day. Bye-bye.
Bye-bye.
Bye-bye.